So section 5.5 is applications, everyone's favorite kind of math problems. Actually, there's only a couple of types in here that I'm going to go over, and it's just to get started, especially if you haven't done these in a lower level class. So example 1, this is a very standard kind of example. And of course they can change the wording in this and they can make it somewhat different. Anyway, it says the sum of two numbers is 24. If 2/5 times the larger number is 2/3 times the smaller number, find the numbers. So the trick to this, first of all, is to make up letters for the two numbers. Now there's two ways to do this. You can use different letters for each number. There's two of them. Unknown numbers, find the numbers, right? The sum of two numbers, it says. It actually means integers, but it probably works out as an integer anyway. Or since the sum of them is 24, you could call one, say, x, and call the other one, say, 24 minus x. But regardless of which way you do it, you should declare your variables. What that means is you write down what variable you're using, and you say right next to it what it represents, what it stands for. Okay, in this case, they're just numbers, so, but they talk about larger and smaller number in the problem, right? 2/5 times the larger number equals 2/3 times the smaller number. Find the numbers. So I'm going to write down x for the smaller number and y for the larger number. Now, again, you could, instead of y, you could use 24 minus x because their sum has to be 24. Whichever way you like better. I'm doing it this way because to me this is just easier, but you just have to get used to using two variables and then eliminating one of the variables, which is one of the skills that we need anyway. Okay, so their sum is 24, so that's easy enough. Oh wait, I got to talk about declaring the variable. Always do that. Now, if you have a diagram where you're labeling things on the diagram, that counts as declaring variables. If you don't have a diagram, though, you should write it out like this. You don't have to write out the declare the variables part, the stuff in purple. Okay, so x plus y is 24. That's just the first sentence. The sum of two numbers is 24. Okay. And they could say the difference of the two is 24. They could do other kinds of things with them. 2 times the first plus 2 times the smaller plus the larger is 24, whatever. Okay, so the rest of it says what? If 25 times the larger number, so I would just write down 25, or 2/5, I keep messing that up. 2/5 times y, and then it says is, so I would write equals, and then it says 2/3 times the smaller number. So 2/3 times x, because x is a smaller number. And I can see that because I wrote it right there. Right, so this one's pretty straightforward. You can almost just read it off of the sentence. Sometimes you have to read the sentence backwards in order to figure it out. But this one we can read it just normally. And then you find the number. So you have these two relations. Now, so what you need to do is solve for x or y in either equation. Either of these equations. Oh, this bracket here just means these are two different equations, and I want to find values of x and y that work in both of these, satisfy both these conditions. Okay, so I'm going to solve for x or y in the first one, plug it into the second, or I can solve for x or y in the second one and plug it into the first. And they're both equally easy here, I think. I think I solved down here. Let's see. Yeah, so what did I do? I cross-multiplied. Remember, cross-multiply. I solved for y, which means this 5 goes up here, and this 2 goes down here. That's all I did. See how fast that is? Those 2's will cancel. Right? So I get y is 5/3 x. Okay, so that's the way I decided to do it. It just looked like it might be easier that way, so I did it that way. But if you did it the other way, it's not that hard either. If you solve for y here and then plug it into here, it's a little more trouble, but it's not too bad. So now I have to plug this into the first equation to get rid of the y's. So we're eliminating the y's by plugging this into the first equation for y. So I replace the y in the first equation here with 5/3 x because y is 5/3 x. And then I'll just have x's in my equation. So x 5/3 x equals x plus 5/3 x equals 24. Then I want to combine the two x terms. And 1 is 3/3, and so I had 3/3 plus 5/3 is 8/3. 8/3 x equals 24. And I just cross multiply, so this 3 goes up here, and this 8 goes down here. And you get that. Now I want to reduce because there's a factor of 4 in here. Actually, there's a factor of 8 in there. I reduce, I get 3 times 3 is 9. Okay, because 24 over 8 is 3. So that's just 3 times 3, 9. Now, what did it ask you for? Always look again for what they asked you for. Make sure you're answering the right question. It says find the numbers. Well, this is what? This is the smaller number. So I still need to find the larger number, so I can use either equation here. I probably use this equation to find y, because it's already solved for y. So just plug 9 in there for the x, and then reduce the 9 and the 3, and you'll get 15. Right? So you just put it in there. That's called substituting, or substitution if you want. And what I did here, I did not multiply 9 times 5. 3 divides 9, so 9 over 3 is 3, and 3 times 5 is 15. You can put in an extra step there if you want, that's fine. And so my answer is 9, 15. And the y value is larger than the x value, so that came out right. Okay. Now you check these answers. And the way you usually do this is to look at the original statement rather than your equations, because maybe you wrote out your equations wrong, right? So it says the sum of the two numbers is 24. Is that true? 9 plus 15 is 24. Yep. 2/5 times the larger number. Okay, 2/5 times 15, you could write that out. I don't think I did, but you can. 2/5 times 15. Well, divide by the 5 first, you get 3, so it's 2 times 3 is 6. And that's supposed to be the same, and you could jot this down on a scratch paper or on your work, the paper on the side of to the side of where you're working on the problem. Gosh, that was a hard sentence to get out. And 2/3, and I want to compare that, what was that, 6? 2/3 times a smaller number. So 2/3 times 9, divide 9 over 3 is 3. 3 times 2 is 6. So I got 6 equals 6. So it checks. Okay.